Welcome back to the next video. Today we will learn another important concept from data structure, that is queue. Queue is used to store data in which data can be inserted from one end and removed from another end. This is called as FIFO principle, that is first in, first out. Consider an example of ATM machine where many people are standing making a line waiting for their chance to come. Normally, we called it as people standing in a queue. So here, the queue means the person who came first to the ATM will get the money first, and the person who will come last will get the money last. So the overall queue means the one who entered first will go out first, and the one who came last will go out last. Now we will see how queue actually works. So here in queue, the insertion operation is called as the NQ and the deletion operation is called as DQ. So here are some of the in queue and DQ operations that we are going to perform on this queue. So in the last videos, we have studied stack. If you can recall the concept of stack, the stack has only one track point or the entry point or the deletion point, which is called as the top, because the stack has only one end to as well as to insert as well as to delete the elements. But in this queue, we need two pointers. One to insert the element. We will use rear pointer to insert the element, whereas we will use this front to delete the elements. Right now, you can remember is to insert we use the rear end, and to delete we are going to use this front end. So right now, just understand how we are going to insert and delete into the queue. We will see how this front and rear value will be incremented and decremented in our next video, that is how to write an algorithm to insert and delete the queue, insert and delete the elements from the queue. So right now, just understand we are going to use one end to insert the value and another end to delete the value. So rear is going to used to insert the data and front is going to delete the data. So the first operation we have here, we have this NQ. So for NQ we are going to NQ this 10. So this NQ means to insert the element into the queue. So this NQ will be happened from this rear end. So when we insert the NQ or we insert the 10 will be inserted from our rear end at the first location. Next is your 20. 20 is, again we will insert this 20 from the rear end, and after 10, 20 will be inserted into the queue. Next is your 30. Same 30 will be again inserted from the rear end, and after 20, 30 will be inserted into queue. Now, next operation is DQ, that means deletion. So here, if you see for the NQ operations, we have passed the elements that which we have to insert into the queue, but for DQ, no arguments are passed because whatever element that is present at the front location, that element will get deleted. So here, after performing this DQ operation, the element which is present at the front. So we are going to delete the elements from the front location. So whatever element that is present at the front will get deleted. So this, after performing the DQ operation, the 10 will get deleted. Now next is again one more DQ operation. So after DQ, whatever the element present at the front So currently 20 is present at my front. So this 20 will get deleted after performing the DQ operation. Next again is we have one more NQ operation, NQ 40. So this NQ will insert it from the rear end, that is from the end side, and this 40 will be inserted after this 30, that is 40. So this is how your insertion and deletion will be performed on Q. From one end, the elements will be inserted, and from other elements, from the other end, the elements will get deleted. So we will understand the algorithm to how to insert and delete in the queue in our next video. Thank you.